Okay, so for this next part, no, I would now be um, partially putting on my industry hat, siguro, and I will now give you sort of like a quick overview on what our course would be about. No, this is about the OpenFlow, Telco, SDN, and NFV. I would specifically focus on the concepts related to software-defined networking and how it interplays with network functions virtualization, which is one of the use cases that are um, used in the industry in general. No, now what I have prepared for us for this part, no, consider this a sort of like an introductory already of the course that you'll be taking on. No? But think of this as in your course, no, you would be having deep dive discussions still on these four key technologies that I'll be talking. No? Now, for today, I will just give you just the tip of the iceberg of these four technologies. What is SDN or software defined networking? I'll also be discussing here what is OpenFlow as a protocol and how it plays out with SDN. I'll also discuss what is virtualization as a technology and its different types. So remember a while ago, we discussed ko that there are different types of virtualization technologies available in the industry for operators and for organizations to implement on. So I'll briefly discuss here, no? And then finally, I'll also discuss what is network functions virtualization or NFV, no? And how it is being supported by virtualization. Okay? Now, what is SDN nga ba? Now, SDN, this is an approach to networking that uses software-based controllers or APIs, application programming interfaces, to communicate with underlying hardware infrastructure and direct traffic on a network. Now, comparing what SDN is versus to say a traditional architecture or a traditional means of networking. And by networking here, I'm pertaining to the transport layer of our communications architecture. SDN is a means for us to have a centralized means of implementing configuration, performance, and control across all of the different transport elements. Now, these transport elements come in the form of your switches. Okay, comparing traditional networking, normally, no, you can say that logically a switch can be split into its two key components, which is the control plane, and the data plane. Now, for those who are not yet aware on what the control plane is about, no? The control plane, this is the logical part of your transport device responsible for um, configuration, fault management, resource management. Essentially, the running configurations in your switches is found in this plane. Okay. Now, the data plane is where the packets are being processed. Okay. So remember that in your switches, you have or it is responsible for up to layer 2 processing. So in layer 2, ito yung sa OSI layer natin. Um, and essentially, this is where the user data is being worked on and being forwarded. Okay, so if I were to simplify it there. Now, traditionally, and by traditional here, by meaning that how we normally go about routing and packet forwarding, is that the functionalities of control and data are isolated on a device perspective. In other words, no, both control and data are represented across the different devices. Now, it has its own advantages and disadvantages, no? But focusing really more on the limitations of this setup that we have, you may have noticed that whenever we want to do configuration, i.e. say we want to already configure a specific route, to our given network, no, we have to rely on protocols, and that protocols would be responsible to propagate the needed information, the control part of that switch, across its adjacent elements, no, or across its adjacent elements and adjacent interconnections, no. Bale, if I were to simplify that even further, no, we rely on protocols to ensure that communication is consistent across the entire network topology. Okay. Now, the limitation there is that on a given scenario, what if, say, I configure a specific protocol on one switch, and then just by sheer human error, I forgot to configure the protocol needed for its adjacent switch. So what would happen? Of course, the packet would not process anymore. Kasi you have to ensure on having the control plane converged and consistent across all of the interconnected elements in your topology. Okay, I mean, it happens na sometimes that you often miss a certain configuration in one network element, and then when you try now to troubleshoot, no, you see that packets are not being forwarded to the destination device. Okay, probably because of human error. So that is one scenario for it. No, now SDN promises to solve one of these issues by already centralizing the control aspect of it. No? So you now implement one device known as the SDN controller, wherein all of the configurations, alarms, and performance management of all of your elements are already found in that one central logical device. Okay? This process is a move away from the traditional network architecture in which individual network devices make traffic decisions based on their configured routing tables. Okay? Now, the architecture in itself, no, moves the control plane that determines where to send traffic to software and leaves the data plane that actually forwards the traffic in the hardware. Kaya din siya tinawag na software-defined networking. It's because the software-defined aspect there is the configuration, or specifically the control plane. No? Dati kasi, these configurations are embedded literally into the hardware part. But through the use of a controller, we can now implement it, although technically it is still software, no, even traditionally itself. The purpose of having an SDN architecture is having a single plane of glass instead of having several device by device basis perspectives. Okay? Now, an architecture, so generally speaking, no, the SDN architecture consists of 3 layers. Okay? And these layers are stacked on top of each other. So first off, you have the infrastructure layer. So this layer is where your switches are located. Okay? This is where your forwarders are also located. Now, on top of your infrastructure layer, you have now your control layer. This is the centralized control. And this is also where the SDN controller, aptly named so, is also located. And finally, on top of your control layer, you have your application layer. The application layer, this is where all other level 7 applications would be residing, such as your load balancers, your firewalls, your policies, no, are placed. Okay. These 3 layers are then interconnected through a series of application programming interfaces, or APIs. Okay. Now, notice that in this diagram that I was able to get, no, where does OpenFlow here reside? It actually resides in the southbound layer between the controller and the forwarding switches. Okay? More of this one later on, no, in the succeeding slides. Now, comparing first traditional networking, or the usual IP-based networking that we have, versus SDN, you'll notice that the SDN, or the software part, the software component here, primarily relies on the implementation of a controller. To put it bluntly, no, in the SDN environment, you're essentially having your switches become, to lack of a better word, no, dumb forwarders. Okay. I say here I use the term dumb forwarders here is because the configurations are no longer being done on the device anymore, at least at least manually. You now depend on the SDN controller to do all of the configurations, and it is now up to to the SDN controller to propagate those configurations across all of the forwarders, no, in the form of flow tables. No? Later on, I'll be discussing this one in detail. Now, comparing traditional networking also to SDN, control is then centralized via the SDN controller. For traditional networking, configuration and resource provisioning is done independently across devices. This is what I mentioned a while ago, that if, say, for instance, you encounter or you forgot to configure the given protocol on one of the devices, and you try to test now packet forwarding, you try to ping one device, no, from the other one, and then you get an error. No? So this is usually the case is because you have to go into the CLI of that device first, configure it first, log out, and then go back again to the other device, configure that device, no, and then log back out again. So there's a bit of a hassle also because you're trying to configure several devices at any given time. And of course, because of that, the risk of having misconfiguration or lack thereof is higher, no? Kasi you have different means of, different interfaces to interact on. Okay? So another one, comparing traditional networking versus SDN, security is implemented independently across the different devices. No? Unlike in your SDN, it is normally centralized. Now, the fourth point here, no, is a bit of a misnomer. This also has a caveat here because security-wise, security implementation can be a double-edged sword, arguably. It's because, yes, you can, it might be better to have security centralized in the SDN controllers only, but it becomes more prone to an attack because once a vulnerability is identified in that controller and that is not properly enforced, then essentially the attacker can take control of the entire network just by gaining control on the controller alone, compared to, say, a traditional network wherein there are still some enforcements, or at least there's a certain level of isolation being done since the configuration is just limited to one device. Okay, so yung fourth one, no, medyo may konting caveat siya. It really depends on how SDN is being implemented, security perspective-wise. Okay, now, moving on, no, I'll now discuss what is the OpenFlow protocol, because I mentioned in the architecture that this is the protocol using the southbound layer where the controller communicates with your forwarding switches. The OpenFlow protocol is a multi-vendor standard defined by the Open Networking Foundation. Okay, this is a protocol used, or this is one of the protocols, in fact, used for implementing software-defined networking. Okay, it defines the interface between an OpenFlow controller and an OpenFlow switch. For you to have OpenFlow, of course, the devices, both the controller and the forwarding switch, needs to support it. And based on industry standards, no, majority of network providers that we have right now, say the likes of, say, Ericsson, Nokia, Huawei in the Chinese, no, Dell, they are also providing, even Cisco. Most of them, if not all, no, already support OpenFlow as its protocol. It may not be their de facto protocol to implement SDN, because there are also some who use proprietary protocols, but nevertheless, they still support it, no, with regards to openness in general. Okay. Now, it allows the OpenFlow controller to instruct the OpenFlow switches on how to handle incoming data packets. Okay. Now, how you implement now OpenFlow in the network, no, would now depend on the compatibility of your devices, both in the control plane and in the data plane. Now, for you to have OpenFlow, you also need to implement it in an architecture. No? So the OpenFlow network architecture consists of 3 layers. Arguably, it is similar to the SDN architecture, wherein you have the application plane, the control plane, and the data plane. Now, the OpenFlow architecture is like an actualization of the network of the SDN architecture. And the actualization here is that what I mean is that think of the SDN architecture as sort of like a high-level framework that whoever wants to implement SDN can use this as a standard template. Okay, if you want now to implement OpenFlow, okay, as an SDN protocol, it is a like for like or nearly identical implementation wherein the SDN controller should have the OpenFlow controller enabled, and the forwarding switches should have the OpenFlow protocol implemented. Okay, the OpenFlow controller maintains the OpenFlow protocol's communication channels to the OpenFlow switches, and it maintains a local state graph of the OpenFlow switches and exposes a northbound API to the OpenFlow application. Now, just to give you again, no perspectives, no, north or northbound here pertains to the OpenFlow controller. Yung communication ng controller plane papunta sa application plane. Whereas yung southbound naman niya is of course yung pababa from controller papunta sa forwarding switches. Okay, so the northbound API may be viewed as an abstraction of the network and allows the OpenFlow applications to read the state of the network and to instruct the network to perform various tasks. Okay, so now you'll notice here also that applications, if say they want to take or they want to utilize now the SDN environment, they can do so through the OpenFlow protocol. Okay, either enabled via an API or called via an API. Okay. Now, let's go inside the OpenFlow switch and see what are its logical parts. Now, of course, just to set expectations, no, if you try to open a forwarding switch, you won't be seeing these components as physical components of the, okay? So this is more of like a logical representation of that switch. Okay, so an OpenFlow logical switch contains what's called the flow tables, okay, a group table, and OpenFlow channels. So based on the diagram here, by the way, no, the diagrams that I have shown here, this is also taken from by standards. Specifically for this one, I got this directly from opennetworking.org. Okay, so based on their definition of what a OpenFlow logic switch would look like, no, it would contain a group table, flow tables. So later on, I'll discuss what flow tables are. Channels, and these channels communicate to your controllers, and of course, you have your metering. This is for monitoring your KPIs or key quality indexes and KPIs, key performance indexes for that switch, as well as the logical points. Okay. Now, using the OpenFlow switch protocol, the controller can add, update, and delete flow entries in flow tables, both reactively and ideally proactively. Okay. Remember what I said a while ago that the controller is responsible for propagating the configurations needed by the OpenFlow switch to forward packets. Those configurations are actually stored logically, no, in the OpenFlow channels of your OpenFlow switch. Okay? So, more details pa, no, about OpenFlow before I discuss what virtualization is. No? If I were to give you a generalized definitions of these components, no, OpenFlow channels, this is the element responsible for communicating or for receiving the configurations propagated by the controller through the OpenFlow protocol. No? These OpenFlow channels are then processed by the switch. No? It uses now group tables and meter tables, which are essentially tables used to keep track of packets forwarded by the switch. The flow tables themselves contain the actual packets. Okay, kaya siya tinawag din na flow table. And you'll notice that a given OpenFlow switch can contain more than one OpenFlow channel and more than one flow table, but it can only have one group table and one meter table. Okay, the group table and the meter table, these are logical tables responsible for keeping track of packets being forwarded, whereas the flow table contains the actual packets being forwarded. I hope that makes sense, no? So, ganun po siya. Now, I'll now go into virtualization. Okay, so we've discussed what SDN is, the architecture, its different parts. We've also discussed the protocol enabling SDN, which is OpenFlow. We've discussed also the different parts found in the OpenFlow switch. We'll now discuss virtualization. So this is a separate topic on its own, just to keep that in mind. No? So first off, what is virtualization? This is a technology that also relies on software to simulate hardware functionality. The byproduct of virtualization is to create virtual machines. Now, what are virtual machines? No? Think of virtual machines as sort of like a computer inside a computer. Okay, so all of us know that computers, whether it be desktops, laptops, or servers, no, it would have the hardware elements. It would also have an operating system, and that operating system is the one managing the applications inside the computer. So, ganun yung parang layering niya. Okay. Once you implement virtualization, think of it na you have one physical device, but instead of it having only one operating system, it can have smaller computers running inside of it, and those smaller computers would have their own operating systems inside. So medyo ano siya, tawag dito, recursive, kumbaga, yung structuring niya, a PC inside the PC. That is what virtualization is about. And why do we even implement virtualization in the first place? Well, if we're going to boil it down, no, it still is in a matter of cost implications, no, coming from the industry. Say you are an organization and you want to install your own web server. Without virtualization, you have to have a dedicated hardware with its own operating system for you to host your server. Ganun po siya. Okay? If say you want a database and say assuming that database does not support or is not compatible with the existing web server that you have no choice but to install or to build another dedicated server that would support your database. So now, for the record, meron ka ng dalawang physical servers doon. Each of them would have their own operating system supporting a unique service. Okay, this was back then. Now, virtualization can save up on installing more hardware by maximizing the already existing hardware that you have. So, given my example a while ago, na meron kang dalawang servers, each of them would have their own operating system, whereby you will now install your web server and your database on two separate machines. Why not have it as one physical server? You only install one, but inside it, you can install two separate operating systems running concurrently, hosting your two separate applications. You can do so through virtualization. Okay? So, having said that, no, there are, as I mentioned a while ago, no, when I introduce the course, and this is also what you'll be encountering later on, no, in the course, we have different types of virtualization. In fact, think of any resource that you have in your computing system. Chances are it can already be virtualized. Okay, so the one that you are seeing here in the slide right now, no, this can actually be categorized by either the virtualization is driven by hardware or software. Now, I got this from IBM. This is their definition of the different types of virtualization technologies available nowadays. No? Now, hardware speaking, you have data center virtualization, network virtualization, CPU virtualization, storage, GPU, no, and even cloud computing. While for software-driven, you have Linux virtualization, application virtualization, data virtualization, desktop virtualization. The type of virtualization that I'm talking about a while ago, na meron kang server, and that server is able to support more than two or more than one operating system running at any given time, is called CPU or compute virtualization. This is the fundamental technology that makes hypervisors, virtual machines, operating systems possible. If I'm going to put here SDN in the picture, and if you if I'm being forced to say na ano nga ba ang virtualization technology supporting SDN, although technically you can have SDN even without virtualization, you can do so through network virtualization, wherein it abstracts hardware elements and functions and turns them into software running on a hypervisor. So majority or based on what we can see in the industry nowadays, no, some providers have SDN enabled through network virtualization. In other words, they can have the controller, the SDN controller, implemented as a virtual machine, no, and that virtual machine is controlling not physical switches, but virtual switches. So the one responsible for creating virtual switches is network virtualization. Okay? With me so far? So, meron na tayong dalawang klaseng virtualization dito na din-discuss, no? So, but the one that I am talking about here is mostly compute virtualization. Okay? Now, you may have also noticed here dito sa table ko, no? Or rather in the diagram here, that why is it that cloud computing is a mixture of hardware and software-driven virtualization? Well, this one I have to argue also with IBM, because think of cloud computing not as a type of virtualization, but as an approach on making resources available to a wider scope. Okay? Kaya nga ang sinasabi din ng sa industry nowadays is that you can implement cloud computing even without virtualization. Okay? In theory. Okay? But in practice, what we have already nowadays, especially on the available solutions and use cases that we have, no, most of the providers implementing cloud, almost 90% siguro, would have virtualization enabled in their cloud. Siguro dun nanggagaling yung standpoint ni IBM on why they included it as a type of virtualization. Think of it also as an amalgamation of all 9 other types. Okay? You don't necessarily need everything to support cloud computing, but you can have at least one of them, in fact. And from my visibility in the industry, no, majority of what we have for cloud computing, we implement it using CPU virtualization. Some of them would have storage, and some of them would even have network. So, itong big 3 ang madalas na meron tayo. Okay? Now, for you to have virtualization, you need that piece of software for it. So, similarly in SDN, for you to have SDN, you need to have the SDN controller. Okay? You don't necessarily need OpenFlow to have SDN, but you can use other protocols to implement SDN. OpenFlow is just one, no? Similarly, for hypervisor, you need a hypervisor to implement virtualization. Okay, this is the critical software responsible for creating your virtual machines. Okay, the textbook um, terminology for the hypervisor is the virtual machine monitor or VMM. Its responsibility is to create instances. Okay, so those instances are called virtual machines, and it prevents those instances from interfering with each other. So example, one operating system which has one VM which has its own operating system goes down or it crashes, no, it's the role also of the hypervisor to ensure that the other operating VMs will not be affected if that given VM or if one VM crashes. So this is more of like fault management na. But this is just one capability that the hypervisor has. It can also be capable of encapsulating the different resources physically into virtual machine instances. Okay? Now, there are two types of hypervisors. So you have the bare metal hypervisor and you also have the hosted. So what do you notice yung difference between the two? No? So in type 1, so type 1 is also what's called bare metal hypervisors. Aptly named so because the hypervisor takes full control of the hardware. Okay, so it runs directly on the underlying computer's physical hardware, interacting directly with its CPU, memory, and physical storage. So in other words, if I were to put this in real life scenario, if you have a server, instead of you installing an operating system, you install a hypervisor directly. That's what's called a type 1 hypervisor. And examples of this, you have VMware ESXi, Hyper-V, and Zen Server. So pag meron kayong server lying around there and you want to create your own virtualized environment, no, you can install either of these three, no, and you essentially now have your virtualized environment. This is type 1. Now, not everybody has the luxury to have their own server installed with a hypervisor directly. Okay, that's where the type 2 hypervisor would come in, wherein the difference is that instead of the hypervisor taking full control of the hardware directly, it interacts with the host operating system, and that host OS is the one managing the hardware. Kaya ang tawag naman kay type 2 is hosted hypervisor. And some examples of these ones is VMware Fusion, Linux KVM, and for your course, VirtualBox. So VirtualBox is a type 2 hypervisor that you also get to experience on once you are already taking the course. The type 2 hypervisor doesn't run directly on the underlying hardware. Instead, it runs as an application in an OS. So the type 2 hypervisor is treated like an application. Okay, so just to show to you an example, no, I think I have here VirtualBox installed. So let me briefly share my screen. So let me stop sharing here. So let me run first hypervisor. So I'll just give you a quick glimpse on what VirtualBox looks like. Okay. Okay, so you're seeing my screen right now, no? So this is VirtualBox. Okay. So in the course, you'll also be asked to install your own or to create your own VM instance. And you'll also be asked to set it up. Okay? So, in my example here, if you've heard of Raspberry Pi, so Raspberry Pi, this is a single board computer. It's just a computer, a palm-sized computer, no? You can take its operating system. In my case, ito yung Raspberry Bullseye, Raspberry VM, and create a VM instance for it. And if I try to start it, so share ko na lang yung screen ko. So here's an example of a VM. Sorry, medyo maliit pala siya. Yan. Yan, okay. So, you'll notice here, no? So here's an example of a VM instance. Take note, this is VirtualBox, okay? This is running in my machine, no? So notice I have here a Mac, but I can install a Linux-based operating system inside my Mac. Okay, so Mac is my hosted OS, and then using VirtualBox, I created or I have a small environment that is Linux-based that I can interact on independently. So this is a fully functional Linux environment running inside my Mac device, and you can implement the same environment here, no? So you can install VirtualBox in your machines and then download a copy of any operating system. I recommend Linux, no? Install that operating system in your created VM instance, and essentially you now have a VM inside your PC. Okay? So you'll be guided naman if you follow yung instructions there to create your own VM instance here as well. Okay? So I'll stop here. I'll now proceed. I'll continue on with our module. So, having said that, no, VirtualBox is also an example of what's called a Type 2 hypervisor. Okay, sorry, I cannot show to you any Type 1 here because it would require me to format my laptop, which I cannot do. No? So, but here you get the point naman. Okay, now, I discussed briefly what is virtualization. No? Now, taking this on a bigger scale again, no, how we implement now virtualization in the telco space, no, we now have what's called NFV. Now, ang concept ng virtualization is that you have now smaller computers running in one physical machine, on one physical machine. What if, say now, those small computers, instead of having web servers or databases running inside of its applications, what if, say, I have a VM that is running a fully blown firewall or a 4G gateway, no? Instead, no? That implementation, it's now what's called NFV, or Network Functions Virtualization. NFV is a way to virtualize services such as gateways, routers, firewalls, load balancers that have traditionally been run on proprietary hardware. Now, comparing a traditional or proprietary hardware or non-NFV based deployment, normally a network function is tightly coupled to its hardware. In other words, no, if gusto kong mag-deploy ng 4G core sa environment ko, I have to purchase a dedicated 4G gateway from a dedicated provider before I can have it in my network. No? NFV plans to change that in a way that it can now decouple the applications or the software part of your network elements and deploy them as virtual machines. That's one part. And then the other part, instead of using dedicated hardware, you can now use commercial off-the-shelf hardware or COTS hardware. This is where your servers would come in. So notice that for you to have NFV, you need to have that V part, the virtualization part. Okay? Because you'll be relying on virtual machines to deploy now your network services. Okay? Now, NFV promises to improve scalability and agility by allowing service providers to deliver new network services and applications on demand without requiring additional network resources. So, comparing now traditional or an appliance-based deployment versus NFV, you'll notice some key difference here is that number one, unlike in your an appliance-based deployment wherein you have hardware dedicated only to a specific application, in NFV, you can have a centralized means of hardware resources or a centralized pool of resources. Each of them can be shared across different functions, which are now called virtual network functions. So that's one part. And then the other part is you now introduce another component here, which is called management and orchestration, MANO. No? So its role here is to oversee all of the different operations running in your NFV environment. Architecturally wise, no, ito yung pinakita kanina, no. So the NFV technology itself follows a standard architecture, and it is developed by ETSI, the European Telecommunication Standards Institute. Okay, so it is the architecture itself is split into three parts. You have your infrastructure. This is where your servers reside. This is where all of the storage nodes, the hypervisor resides. The applications, the virtual machines reside here. They are now called virtual network functions. And the one managing all of the resources that you have is called the MANO, or management automation and network orchestration. Now, in some terminologies, they also just have this as management and orchestration. But either way, it's fine. So, meron kang NFVI, meron kang VNF, meron ka ding MANO. Okay? Now, yung course ninyo itself would, again, deep dive yung mga definitions of these components and how they are being used alongside NFV. Ngayon, I just limit it for now to these three technologies kasi once you start working on with the course, no, you'll now have an intensive view on how does now these three interwork with each other to form a bigger picture or a bigger solution. Okay? So, yun. And just to summarize everything, no? So, I hope, no, medyo memory overload tayo ngayon. I hope you don't mind, no? OpenFlow, again, this is a protocol. This is an open source protocol developed by ONF to implement SDN. Okay? SDN, this is an approach in networking to decouple the control plane from the data plane. Okay? You can have SDN using OpenFlow protocol, but it is not a requirement. You can implement SDN using other protocols available right now. The reason why we opted for OpenFlow is because this is the open source protocol available to everybody. Not all protocols that support SDN is open source in a way. Okay? But nevertheless, it is still supported. Okay? The second part is virtualization. So virtualization, this is a technology that relies on software to simulate hardware functionality. And if you scale this one up to the telco perspective, no, you have network functions virtualization. You can have SDN and NFV working together as one end-to-end solution. But you can have either one. You can have just SDN. You can just have NFV. Okay? And I believe that wraps up my talk for this morning. I hope this was insightful for you guys. No? This is just the tip of the iceberg of our course. More of the details can actually be found in our course pa. Such as the different functionalities. If I were to go now into your SDN, yung mga different use cases na, yung mga different applications, no, the protocol itself would be discussed in the course. Yung different parts of the OpenFlow packet header would also be discussed there. With regards to NFV, the architecture would be discussed deeply, as well as its different use cases. Okay, so having said that, no, that concludes my talk for today. Thank you very much. And I hope this session was insightful to you. So I now turn it on. So after this, I think we have a Kahoot for post-exam. Ayan.
Yes. Let me just share my screen. Thank you, Liber. And
Thank you.
before we okay. Yep. So I already shared my screen and join the post test for Kahoot. Okay.
Nawala si Richard. Hello, nawala
Sorry,
si... Oh,
nawala
there he
si,
is.
si Richard. Ayun.
Richard, are you back?
Yes, yes.
Okay.
Sorry, naputol yung connection ko.
Pauuwiin ko na sana sila eh.
Before I complete the post. Okay, so yeah, we can start our Kahoot. Yes. Okay. All statements about the diagram are true except The architecture is a traditional network.
Mukhang nag-improve na, ano, Chard.
Number 2, determine which type of network decouples the control both conventional and software-defined networks. Conventional networks, conventional networks, software-defined networks. Number 3, this software is responsible for creating virtual machines, the controller, hypervisor, file, or a hypervisor. Okay. Number 4, what makes type 1 hypervisor different from type 2 hypervisor? If the type 2 creates an environment where VMs are instantiated, type 1 restaurant, type 2 needs a another stick part 2. Okay. Number 5, SDN is open source. Is it true or false? False. Number 6, which of the following does not belong in a typical SDN architecture? The control layer, application layer, infrastructure layer. Okay. Dudes and Benjamin is back on top 1. Number 7, how is SDN different from traditional network? SDN is purely hardware-based. The configuration and resource done independently across devices. Or is it control is centralized or decentralized? Okay. Number 8, pick the phrase that best describes software-defined networking or SDN. A network device with advanced features, protocol that enables communication between network devices, an architecture that separates the network, control and forward functions, or an application that can manage network. And we go to our 9th question. Which part of the NFV architecture is responsible for managing the hardware resources? Is it the VNF, VNF, the VIM, or the NFV? And we go to our last question. Which of the following statements are true about OpenFlow switches? Use flow tables to route require virtualization to work, or use to communicate with SDN controller, or do not communicate with an SDN controller. Okay. Now let's see, sinong ating top 3? Top 3 si RB. Top 2 si Dudes. And top 1 ay sino si Benjamin. Okay, so yep, so that's our post test in our Kahoot. And before you go, no? Wait. Nalilito ako dun sa aking yan, close ko muna. Ating ano. And before you go, let's award the certificate of appreciation, no, to our industry expert for today. Okay, let me just present the certificate of appreciation. So Asia Open Academy is pleased to present the certificate to Liberius Enyo Taruk in grateful acknowledgement of his engagement and insightful academic contribution as a resource speaker in imparting unparalleled knowledge and expertise in OpenFlow, SDN, and NFV. During the USAID webinar on advancing Open Run in Asia, funded by the United States Agency for International Development, Asia Bureau, and its Asia Open Run Access Network activity under the Indo-Pacific Opportunity Program held on September 9, 2023 via Zoom webinar from 10 a.m. to 11 a.m. Signed by Glenn Mackenzie Fraser, Chief of Party, USAID IPAP. So let's give a round of applause to Liberius and greet him happy birthday for today.
Ay. Thank you po. Salamat. Ba't yung
Yes.
sinapin?
Happy birthday.
Ba't yung sinapin?
Happy
Thank you.
birthday.
Thank you po.
Okay.
It's been a pleasure. Oh.
What's our schedule next Saturday?
So by next Saturday, it would be, let me just go back sa ating schedule. Okay. So by next Saturday, it would be cloud computing. Yan, by September 16. Yan, nasa cloud computing na tayo.
Andiyan yata
So,
si Raymond.
Yes, nandito po si Raymond.
Okay, so I think we're over time. Let's wrap it up.
Okay, thank you so much, and we'll see you again next week.
Thank you.
Thank
Thank you,
you.
Sir Raymond. Thank you, Maria.
Thank you, everybody. Thank you.
Bye,
you, Cyber.
everyone. See you next week.
Bye-bye. Bye-bye. Thank you.
Ay, natapos.
Yung mic mo naka-on pa, Noel.
Okay, bye.
Bye-bye. Thank you.
Thank you, Liberius.
Thank you,
Thank you, Globe. Nako, magkasunod na Saturday, Globe ang ating industry speaker.
Mhm.
Okay, so I hope we have someone else for next Saturday. Are we all set?
Hinihintay pa po natin mag-reply si attorney sa ano.
Okay. Thank you, Richard. Bakit ka naputol?
Hindi ko pa alam, pagka nagta-transfer ako ng ano sa Zoom, nag-shutdown si Zoom eh. Bigla siya
Nagta-transfer ka
nawawala.
ng to
screen
Kahoot?
kay po.
Huh.
Pero yung Kahoot di naman eh. Kaya akala ko kanina naka-connect pa rin ako. Nakita ko na lang pala yung kasalita.
Ay, nako. Okay.
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 Thank you.
Thank you. Bye. Have a good weekend.